Okay, we've got a speed time graph here, so speed here, time here. We want an estimate for the acceleration. So acceleration is rate of change of speed, which is gradient. So rate of change of speed, which is the gradient, but you'll notice this is a curve. Now gradient is the steepness, and if I roll this ruler along the curve, do you notice that as I roll the ruler along, it's changing its angle, so it's changing its gradient the whole time. There isn't a constant gradient for this whole curve. So to estimate the gradient at a point, we're going to need to figure out what point we want it at. So this one says at t equals 2, so that's time equals 2. So first, I'm just going to draw a little gentle line up so I know it's this point here that I'm looking at. To estimate the gradient. Now, you might remember back in the day, when you first did gradient, you'd have a straight line, wouldn't you? And you'd count squares along and squares up and you'd work it out. Here, we don't have a line along. So what we do is we try to draw a tangent. If you remember, tangents are lines that touch at one point only. You'll notice that it's quite easy to draw a variety of different ones here. This is why it's an estimate. Basically because until you get to A level, you're doing the best you can with it. So I'm going to draw my tangent here. Make sure it's nice and clear that you've got a tangent there. And then all I'm going to do is I'm just going to work out the gradient of my tangent. So this has got a point here, this has got a point here. When I go along one square, I go up 2. So along 1, up 2. Then I need to work out what one square actually represents, which I'm looking at this. That would be 1. So each 1 is 0.2. And each up, well, that's actually 10 whole squares. So each up is actually 2. So that's 2 divided by 0.2. which is 10. So 10 meters per second to the minus 2.